can bring the first team in. Yep. All right, guys, I'm going to turn off my camera and remove the sharing. Okay. All right. Yeah, coming in. Let me know. Yeah, got it. Yeah, just end it there. Okay, coming now. Hey guys. So Team Amtel, who's presenting?
Four of us are presenting.
Okay. So whenever you're ready, you can put up your slides and start. So you got 15 minutes for presentation, 5 minutes for demo, and then they have 10 minutes for Q&A. Yeah. I will give you a heads up before you reach 2 minutes for your presentation. Okay. All right. All the best, guys.
We still have one more members haven't come.
Yeah, I think you got everybody in. You can start now.
Good evening, ladies and gentlemen. My name is Yo Ming from Intel Group of University Science Malaysia, and I'm here today to talk to you about how Intel Bot enhance the customer shopping experiences. Before I start, let me do a simple introduction about my teammates. Me, Yo Ming, as the project leader, along with Tan Kai Sin, responsible to design the prototype and code the interface. Next, my teammate Tan Junjie is one of the demonstrators of the project, and Shamiran is the hardware engineer of the Intel bot. These are the photos from different views of the Intel bot, and it has a cool name, which is Brian. We invented Brian based on ways to increase the efficiency of the cashier and save the customer's queue to enhance their shopping experiences. Can you imagine that? When you are going to a supermarket at the peak hour, you can see the low efficiency of using a human cashier to check out the customer's product. As you can see in the picture on the left, a cashier is checking out a basket of products, and there's another more trolley of products waiting there for her to be checked out at the same time, and so on. Other than that, there are some self-checkout kiosks that face long queues during the peak hour. Both reasons are causing the supermarket to become a large crowd of people. Next slide. To achieve Sustainable Development Goal number 9, build resilient infrastructure, promote inclusive and sustainable industrialization, and foster innovation. Our target is to support domestic technology development and industrial diversification. Therefore, our objectives of the project are to develop a portable self-checkout kiosk that can be moved anywhere as customers like. The customer can make their payment anywhere, anytime, without queuing. Besides, we want to make the recommendations on the new trend in the supermarket, as nowadays there is only a few of such technology in Malaysia. Lastly, we aim to reduce the cost of supermarket assets. This is because I assume that the cost of buying Brian is lower than a self-checkout kiosk. The estimated cost of both machines will be shown later. I believe that every entrepreneur wants to use a low budget to buy a high quality ratio product. Thus, I think Brian is more suitable than a self-checkout kiosk. On the other hand, for merchants with limited financial resources, we also provide small amounts of exportation to them. With limited Brian in the big supermarket, the merchant can encourage people to become their members to experience this premium treatment. Now, I will pass my mic to Shamiran to talk about the statistics that we researched.
Good evening. My name is Shamiran, and now I'll proceed to explain three statistics that are related to our project. The first one is labor shortages. As of right now, many regions are facing a shortage of labor in industries such as manufacturing and logistics. The World Economy Forum reported that by 2020, there could be a global workforce shortage of 85 million people. Therefore, Brian offers a solution by automating repetitive tasks and reducing the dependency on human labor. Secondly, operational costs. By implementing Brian, we can significantly reduce the operational costs. A report by PwC suggests that automation can reduce operational costs by up to 60% in some industries. These savings are achieved through reduced labor costs, lower error rates, and optimized workflow. And lastly, long queues. A survey had been done and it showed that 70% of customers are required to wait for 30 minutes or above for their turn to make a payment in the US in the year of 2016, which can be solved by by using Brian because Brian can help reduce the queues. For the marketability, we have come up with three questions. Firstly, who are our target customers? Our target customers involve supermarkets such as Lotus, Super Shine Square, Aeon, and 99 Speed Mart. They get the benefit from Brian to enhance customer experiences and optimize overall supermarket's operation. What are the strengths of our market? The strengths of our market is to enhance the payment process, increase efficiency, and reduce staff costs, and increase revenue of the supermarket. And lastly, how big is the market? For our market size, we will consider the four following aspects: geographics, demographics, psychographics, and behavior. So now I'll further elaborate the four aspects of our market size. So first, geographics. Brian can be sold anywhere around the world, and as long as the markets have deployed the self-checkout kiosks, Brian can be deployed. Second, demographics. We will target the supermarkets which have a high demand for portable self-checkout kiosks. Third, psychographics. We will target the supermarkets that are innovative, customer focused, and prepared to invest in technology that improve customer satisfaction. And lastly, behavior. We will target the supermarkets that have already implemented automation technologies and the supermarket that invests in advanced technologies.
Good evening. My name is Tan Kai Singh. I will present the components and implementation of Brian that is designed to improve supermarket shopping experiences. First, Brian has crucial electronic components which are essential for managing Brian's operation. Intel real-time camera for security and membership verification via face recognition. Barcode scanner for fast input of product code identification. NFC card reader for seamless membership verification and credit card payments. Touchscreen monitor to display and enable customer to interact with the system. Next, the Brian's physical structure guarantees the mobility, which are the chassis and wheels to enable effortless movement in the supermarket. Lastly, the software components include an user-friendly interface for smooth interaction with customers to enhance their shopping experiences. Now, we will continue with the system interface. Here are two buttons. Previous slide. Membership login button for supermarket member and site address button for non-member. Next slide. On the membership page, members are needed to verify their identities by using their membership ID and faces. Non-member can start shopping easily without this process. After that, the main menu page allows customers to scan product and add it to cart. These are the payment interfaces to allow customers to make a payment according to their preferred methods. Once payment is done, the payment successful interface will appear and sending an e-receipt is optional to customers. Following that, these services are provided to customers, which are contact staff for help, market map, give feedback, FAQ, and about us sessions. These are the following pages for map and feedback sessions. Lastly, only members can access this page and view their membership details.
Good afternoon, judges. Now, please let me introduce to you our competitive analysis. We have made the competitive analysis between Brian and self-checkout kiosks in three aspects. Firstly, the efficiencies. Brian able to reduce the long queue during peak hour, which the self-checkout kiosk cannot reduce the long queue. Secondly, portability. Brian is able to follow or control by the customer to move around the shopping center, which self-checkout kiosks cannot do that. This means that Brian is able to bring a more convenient shopping experience for the customers. The third aspect that we compare is the cost. As you can see, we write in the slide, the prototype for Brian is around $1,000 to $1,300 US. And for the cost for a self-checkout kiosk, the cost is around $1,500 to $5,000 US. As you can see, we believe that Brian has a lower price, but we want to make a reminder that this is a prototype, and we expect that the complete product may increase with the cost by 2 times. However, we still believe that this Brian has a lower cost compared to the self-checkout kiosk. By showing this proof, so as you can see, this is the bills of material that we bought to build out Brian, and it total costs around $178 US. This is the price that we are using to build out the prototype Brian. Now, please allow me to show you the demo of the Brian. We will demonstrate the member login method. The member will need to use their access card to log into the account. The member will need to use face recognitions to verify their identity. Once Brian verified the member are allowed to start the shopping. The member are allowed to check on their profile. Members are allowed to call for help from staff through Brian. Brian will send the location of the customers to the staff. Brian provides map function that record the location of all these goods. The member can click on the specific column to get to know the category of the product. Brian also provides feedback function, which member can leave their feedbacks and comments. Member can know more about the supermarket as well, reading through this information that we provided about the supermarket. Member will need to scan the barcode of the product so that the product is recorded by Brian. The detail of the product will be shown on the screen by clicking Add to the Cart button. The item will be recorded by Brian. The member will perform that when they want to buy this thing. So this is the checklist of the customer, and the member can amend their checklist. User can remove the item from the checklist as well when they found that this product. Brian also allowed member to make payment through debit card, credit card, e-wallet, and membership point. Brian will show whether the member has a sufficient membership point or not. When the member chooses to pay by debit or credit card, they will need to scan their card with the scanner. Brian will send an e-receipt to the member mailbox. Now we will show the guest login method. Brian will notify the user that the user will not get any membership point. The user will not allowed to track on their profile. The guest users are not allowed to pay with their membership point. If the user wants to pay with e-wallet, they will need to show the QR code of the e-wallet to Brian. Once Brian detected the QR code, it will proceed to the payment.
Yes, you have 5 more minutes.
Now we will show the real-life scenario demo. Customer can use a remote control to control the movement of Brian so that it can move to the desired places. Thank you. And please allow me to introduce to you our future improvement. Firstly, we would like to add the auto-following features into Brian. As you can see, Brian need to be controlled by remote control, and we think that it would be better if we can add the auto-following feature into Brian. Secondly, we want to have a hand-free design in Brian. As you can see, just now, the customer need to key in their email address in order to get the e-receipt. However, we want to improve Brian by minimize the chances of the user to type their informations. Now, let me introduce to you our business model. Firstly, we introduce the premium customer, which is only members of supermarket can enjoy the Brian. This is for the beginning phase. And for the later phase, while the supermarket wants to introduce Brian to everyone, including the non-member, so we can still have the additional functions such as map or call for help to be made restricted to the normal user. Only member user can enjoy these functions. This is to attract more customers to be the member of the supermarket. Secondly, we want to improve the features by adding upselling and cross-selling features in Brian. Brian will make recommendation of higher quality products or related products to the customer according to the checklist of the customers. These two are the impacts of Brian. Firstly, Brian is able to enhance the customer loyalty. Brian will enhance the customer shopping experience by providing a more convenient shopping experience. This is able to attract more customers to the shopping centers. Besides that, Brian is able to increase in efficiency, and Brian is able to reduce the numbers of workers. Hence, it will increase the revenue of the supermarkets. So in summary, Brian is a solution for increasing the efficiencies of cashier and removing the customer's queue time to enhance the customer experience. Brian allows customers to make payment at any time, anywhere. This provides a convenient shopping experience for the customers. Brian is a trend that will revolutionize the way people shop. That's all from us. Thank you.
Thank you. We still have plenty of time, so open the floor for Q&A from the judges.
Yeah, I have a couple of questions. This is Shaji from Retail Ethics. Good presentation, guys. Can you hear me?
Thank you, sir. Yeah, we can hear you.
All right, a couple of questions. So when you were working on this idea, did you go and do some research? Did you go and survey some shoppers?
Yes, yes, we did. So actually, we study about the statistic, as you can see. So we study about the reasons why the online shopping will exceeding the, face-to-face shopping, and we find that the highest reason is online shopping will be more convenient. So we come up to this idea. So we hope to solve the question.
No, what I meant is, like, have you gone to any of the supermarkets or something and spoken to actual shoppers, about this idea? Like, did you share with them, hey, is this a problem you're facing? Long queues and, the self-checkout is not good enough or whatever. Did you get some kind of feedback from?
Sorry to say, we have not.
Okay, no, that's okay. Did you have any chance to speak to any retailer about this idea? Did you? I know it's difficult, but I'm just wondering, have you had a chance to speak to anybody at all, like a store owner, even a convenience store owner, anybody at all?
No.
Okay, doesn't matter. So how do you validate? A couple of things I picked up. So just clarify this. I didn't really get it, but customers or shoppers need a remote control to control this. Is that what you're saying?
Actually, rather than a remote control robots, I think they need a payment kiosk which they can pay anytime, anywhere. Because as a customer as well, I would like to have chances to pay anytime, anywhere, which I like. So I will no need to go to have a long queue.
Okay, so this is actually a kiosk that is portable, that can move around.
Yes.
You can put it anywhere. That's what you're saying.
Yes. It will be following.
Okay, I get it. So okay, all right. So it's not in a fixed area of the store.
Yes. It will follow the customer whenever the customer goes.
I see. So I saw something in your interface. You can add products and you can remove products, right?
Yes.
But so that's only on the interface. But how can you validate that the actual physical product was removed? So that means I'm paying for lesser items if I don't remove that product from the basket. You know what I'm trying to say? So for example, in your basket, you have, let's say, you have 10 items, right? One of the item is, let's say, a pasta sauce. Okay.
Yes.
So on the interface, I saw you doing that. You remove the item. You said customers have a flexibility to remove the item, right?
Yes.
So you remove the item, but how do you know that that physical product was removed from the basket or not?
I think I can answer your question.
Yeah, sure.
Like like the shop, like the supermarket now in Malaysia, if we don't scan the product, if we don't pay the product, and we go out from the supermarket, there's a gate, right? The gate will alarm when we bring out the unpaid product. This is the same with the supermarket. Like we remove the product, then means we don't pay the product. There's the security gate and the main gate. Before the After the customer go out from the main gate will also be ring because of the unpaid product.
Okay, that's not entirely true, but it's okay. You guys got to do a little bit more research. So that is because that works in a department store, in a fashion retail, because you have RFID tags. But when you don't have RFID tags, it doesn't work. So that's not how it works. Okay, never mind. But you guys need to do a little bit more research on this, because you're trying to come up with a product that you want to commercialize, right? So the people who are buying are not shoppers. The people who are buying are the retailers. So these are the questions they will have. Hey, how do I know people are paying for the stuff, that they removed, but how do I know they didn't remove it from the basket, right? So you need to answer some of their concerns as well. So you need to think about that whole process. But otherwise, yeah, great job.
Thank you.
That's all from me.
Thank you, Saji. Other judges, please.
Yeah, I have a question to the team. Hi, I'm Nadia from Intel. So I want to understand how you guys are going to propose this to the supermarket, because you mentioned that the robot itself will follow the customers, right? I mean, for example, how do you select the customers that get the portable kiosk, or yeah, how are you proposing to this on this?
Sorry. So your question is asking how should I propose to a supermarket, right?
Yeah, I want to know, because you said this is a portable kiosk, and
Yes.
at the same time, this robot will follow the customers.
Mhm.
How is on the supermarket side, if they have this portable kiosk, and then you said that this robot can follow, and then they can pay anywhere, anytime. Does everyone in the supermarket get one robot, or only selected customers get this robot?
Oh, I see. Okay.
Yeah.
So please allow me to go back to the slide. Yeah, this one. So at the beginning, we want to propose this Brian as only a premium features for certain customers. Yeah, because firstly, we want to get about the feedbacks, whether the customers will really enjoy this feature or not. So at the beginning, we only set Brian as a premium features. So which means that Brian is only applicable for those who are member in these shopping centers. For the customer who are just a normal customer, they can't use Brian. So this is for the beginning phase. So for afterwards, when the supermarket finds that Brian is a really good selling points, so we can make Brian's common features for all customers. However, in order to attract more customers to be a members, so maybe we can add some restrictions, like we restrict some features in the Brian's, like map or calling for help. So these features only open for the member of the supermarket. The common customers who are not a member, it just only can use the shopping features, but not other features.
I want to add something. To achieve the auto following robot, we are plan to using the beacon tag, which means the customer the customer can bring the tag and walk around, and the robot will follow him automatically.
Okay. Yeah. Thank you.
Sorry, follow-up question. So how will you collect those tags back? That means there's got to be a security still.
There will be a storage box on the robot, and then the tag will be putting inside. if they don't return the tag after they go out from the security gate, the gate will also be ring.
Okay.
Questions from other judges?
Hi, Najib here from Ranti. So I'll not address the what other judges have already commented on. But all in all, good presentation, good words in there. Well, kudos also to your demonstration. It was clearly it was a good demonstration. But then your messaging in terms of what your value proposition, how do you increase efficiency of the cashier? This needs to be tightened because as it is right now, the relationship with the cashier is very much is non-existent. You're basically improving the whole payment process of the user or the shopper, right? So that needs to be tightened. If it has no relation at all with the cashier, I mean, say as it is, because you're basically paying to this portable payment thingy or whatnot. Yeah, that's one. Supermarket, you mentioned that, yeah, you're going to go into all the supermarkets. You mentioned about what Aeon, all the supermarkets. This one you may need to segment the supermarket itself as well. If you're still looking at it from from a moving robot perspective, if I'm not mistaken, Speedmart, the lanes are pretty small. So you need to see whether your robots can even go to the lanes of Speedmart. So, or you need to establish that your robot is not even technically viable for supermarkets like Speedmart. That's one thing, yeah. Notwithstanding who will be able to pay for your products, I'm not addressing that. Yeah, going back to what Shaji mentioned earlier before, the mention about the remote control, and I think Junji also mentioned about this is more of a auto following robot, but the auto following robot is in your future roadmap. Yeah. So if it's day one, if it's a remote, so the question still remains: do you expect the user to, well, I have my card and I'm holding my card and I still have to control this. When I'm ready to pay, I need to control the robot to come to me and I can start paying for my thing. So the user journey seems a bit disconnected. So relook at that. And Shaji's point about well, go down to the ground in terms of the supermarkets, do it yourself, go and buy something, go and pay something, see whether your robot is able to really deliver what it has. That's all.
Thank you.
Thank you so much, Mr. Najib.
Okay, Asmawati, any question?
So far, I'm clear. A good presentation. I think in terms of idea, but from my point of view, I think you should have engagement with of course, the store and also the customer to get their feedback on the application and features of the solution that proposed. That for me, right?
Okay, if no further question, thank you, Team Amtel. So you can leave the judging room now.
Okay, thank you, judges.
Okay, thank you, judges.
Thank you so
Thank
much.
you, judges.
Judges, you can start, scoring. I'll give you a couple of minutes before bringing the next team. Judges, you okay? We'll bring the next team in.
I'm okay on my side.
Good.
Team Blackbox, how many people are coming? Your team?
We have 3 people here because the other 2 are having their final exam.
Okay, all right. Okay. And it's coming. All right. So you got all 3. So you can start, put up your slides, and when the judges are ready, you can get started. So you have 15 minutes presentation and 5 minutes for demo, and then 10 minutes Q&A from the judges. All the best.
Okay.
Very good judges and everyone present. We are Team Redbots from and we are excited to present our innovative solution, Robocart, which is an advanced smart card that can help us to find items and transport items autonomously. We have 5 members, and each bringing unique skills and expertise to the table. Guiding our efforts is our respected supervisor, Dr. Adams.
Sorry, guys, are you showing the right pages?
Sorry, I try again.
I think the audio wasn't clear. Which team is this?
Redbox. Okay. Got it. All right, proceed.
A very good day to our judges and everyone present. We are Team Redbots from Utah, and we are excited to present our innovative solution. It's an advanced smart card that can help customers to find items and transport items autonomously. We have 5 members, and each bringing unique skills and expertise to the table. Guiding our efforts is our respected supervisor, and the problem that inspired Robocart. Cameron will provide insights into our design process, explaining on our development methods and project processes. Lastly, Cameron will discuss the impact and value of our project, and then wrap up with a summary and closing remark. In Malaysia, shoppers often struggle to find specific items in large stores like Lotus. Imagine being a customer in an unfamiliar store looking for a particular product. You might browse categories or ask staff for help, but these methods are not always effective. Navigating a large store can be challenging, and finding staff may not guarantee assistance. This frustration leads to longer time. To tackle this issue, we present a solution, Robocart, a voice control robot that acts as your personalized shopping assistant. With navigation and carrying capabilities, Robocart enhances your shopping experience, find items and provide guidance, making your trip more efficient and enjoyable. Now, let's dive into our problem statement. We have identified the problem, and now let's discuss how we plan to address it. In Malaysia's supermarket, efforts to efficiently find products not only lengthen shopping trips, but also reduce overall shopping satisfaction. Shoppers often face challenges in locating specific items within large stores, as well as encounter difficulties in moving their items effectively. To tackle these issues, our project combines 2 key components: an item localization feature inspired by a smart card and the functionality of motorized luggage, which offers user-controlled electric movement. We studied the existing smart cart functions along with the motorized luggage functionality, and come out that we can combine the strength of an innovative feature of the robot. So basically, the existing smart carts are able to find and guide customers to the product location, but they still need manpower to move. On the other hand, the motorized luggage is capable of electric movement, which allows user control, but it cannot help the user find or be guided to the location. Compare the functions of our innovative robocart with existing solution on the market. Our robocart is able to build and deliver comprehensive solutions that include finding the location of an item and guiding the user to the correct location, moving without manpower, autonomously following the user while carrying the item, and user-friendly voice control. The comprehensive set of features positions robocart as a unique and advanced solution in the market. In order to achieve these functions, we developed a comprehensive approach to creating our innovative product within a time frame. Our design relies on Navigation 2 for navigation. Navigation 2 is the professionally supported spiritual successor to the ROS navigation stack. It can ensure a precise movement in the supermarket. To navigate smoothly while avoiding obstacles, we rely on ROS 2 to obstacle avoidance capabilities. We also employ image processing techniques with OpenCV to detect humans. Once the robot detects a human, Navigation 2 can autonomously follow them, even while they're on the move. We have also built a voice user interface by using speech-to-text and text-to-speech technologies to allow the seamless communication with robocart. Lastly, we use the power of AI, specifically GPT model from OpenAI, for natural language processing. This enables the robot to understand and respond to user queries intelligently. These design elements come together to create an intelligent and versatile shopping assistant in the form of robocart. It also allows us to develop in a short period.
Now, let's introduce the workflow of robocart. Basically, the robot will first be initializing its camera, speaker, and microphone. Upon activation, robocart will actively listen to users. It will identify the user's intent and make decisions amount to follow user to find item or to stop. After recognizing the user intention, the robot will respond accordingly. For example, if user send lead me to the shampoo area, the robot will retrieve shampoo location from database and navigate user to the shampoo area. When user done using robocart, the robot will automatically move back to its charging area and wait for next customer or prepare charging by staff. That's our overall workflow for robocart. In addition to original components of the robot, we also purchase some additional components. First, we equip robocart with a basket that can be easily loaded and removed. The idea is that the robot should be able to carry items and the basket should be picked up and passed to the location when users want to make payment. Therefore, this is another point where the user experience can be improved. Secondly, the tag is used to secure some small components. For example, we use the tag to stick the antenna to make sure it stays stable during locomotion. The USB sound card is used to convert USB port into audio port and ensure speaker and microphone can be connected to the robot. Lastly, the speaker and microphones are applied to perform voice interaction that provide two-way interaction between user and robot to improve user experience. Besides of hardware components, we also have invested in the OpenAI API to enable natural language processing capability. But the cost of the API depends on frequency of conversation, so it is hard to tell about an exact amount, but we can say it will cost about half-cent per conversation. The overall cost, additional components and investments remains budget-friendly, totaling less than 100 ringgit. These enhancements integral to make robocart an intelligent, reliable, and cost-effective shopping assistant. To ensure flexibility and responsiveness through the project, we adopt agile methodology. This allows us to iterate, adapt, and refine our product continuously. Besides, we take on different roles and responsibilities in this project. First, the project manager is responsible to overall development process, ensuring that goals are met and resources allocated effectively. The next role, software engineers, is actually taken by 5 of us to develop the necessary functions, ensuring our robot perform work effectively. The hardware engineers is responsible for materials decisions and robot assembly. The prototype designer creates the initial design and concept that serve as blueprint for robot CAD development. Lastly, the display designer is responsible for crafting user experience. Our work progression involves 6 key phases. We start with the first phase, which is to build autonomous mobile robot. Tutorial for ROS2 and LV2 was done by our lecturers, Mr. Teo Seng Han and Ms. Stanley Ng. Our supervisor, Dr. Oi, provided guidance for developing a human detection function and voice control interface. In addition to primary guidance, we also refer to several external resources such as YouTube, ROS2 documentation, and LV2 documentation, and other more to enhance our project and incorporate effective features.
Hello everyone, my name is Chu Kian-boon, and I will continue the remaining parts of the presentation. Our project starts at the end of June. We began with the training, and the training includes how to assemble the scouter robot, how to develop the ROS2 system and navigation on the robots. Along with training, we assemble the AMR and get it done before August. We then learn how to develop the main features such as human detection and voice control from July to September. After we learn the skills, we start to develop if functions. The testing process is conducted with the development process to make sure all functions can perform well before being integrated with other functions. For the testing, we have conducted 3 main feature tests. First, the human detection function plays a vital role in the entire system workflow. So we tested that the system may target more than one object, and we solved the problem by making the system choose the object with the largest area. However, this function still needs to be tested, and we will test it more on various test cases to ensure it can comprehensively work. Secondly, the voice user interface is tested to ensure the robot is able to seamlessly interact with users. We conducted tests in different environments, and we found that distance can impact the accuracy and consistency of the user interface. And to solve this issue, we increased the audio decibel level. This problem has been partly solved, but we will make more efforts to develop a more effective method to enhance the user interface. Lastly, the item location retrieval function is required to search for the location of products. This feature is important because it will affect the navigation function's accuracy. So it's needed to test because there will be plenty of data in a large supermarket. Although we haven't tested it with a large and diverse data set, we will pay attention to this issue and implement a test. As the impact, our product can be used immediately without the need for major changes for the environment. For both users, staff, and customers, there is a quick learning curve, so it can ensure a smooth transition. Also, by implementing our product, staff workloads can be significantly reduced as the robot assists with transportation and navigation. Implementing our product is straightforward for buyers, as the regular charging is only the primary requirement. Also, it is user-friendly for customers, as it only requires natural conversation for control. However, there are a few points to consider. First is the environment noise may affect the accuracy and consistency of the voice control. Second, a stable Wi-Fi connection is essential since our system relies heavily on the internet for its features. And lastly, our robot currently supports only English language. And our project, RobotCart, brings significant value to the market in multiple ways. In terms of marketability, it serves both internal and external customers within the supermarket ecosystem. It enhances the shopping experience, improves operational efficiency, and has the potential to expand beyond Malaysia into the global supermarket automation market. From a commercial perspective, our project was developed at a cost of 15,000 and offers a selling price of 18,000. But to this set our project RobotCart apart is the uniqueness in offering the autonomous navigation while carrying items, voice control, and the ability to follow moving objects, which is a comprehensive solution in the Malaysian market. Moreover, as we increase our production volume, we anticipate the potential for reduced pricing in the future. But our initial focus is on the supermarket sector, Robocars will supply capabilities extend to other markets, such as elderly care facilities, warehouses, and public transportation due to its autonomous transportation and navigation functions. In conclusion, our project, Robocart, is poised to revolutionize the shopping experience in Malaysia and beyond. We have addressed the challenge of efficiency locating items in large stores and transporting autonomously, offering a solution that enhances convenience and efficiency for both customers and staff. Robocart has unique features like autonomous navigation while carrying items, user-friendly voice control, and the ability to follow moving objects. These capabilities set it apart as a comprehensive and innovative solution in the Malaysian market. Our agile development approach, along with the dedicated efforts of our team, has been enabled us to create a versatile shopping assistant that can easily adapt to various environments, including elderly care facilities, warehouses, and public transportation. Furthermore, we have developed at a cost of 15,000 and maintain a selling price of 18,000, making Robocars an attractive option for business seeking to enhance their services. As we move forward, we look forward to the opportunity for future refining and expanding our product to provide even more value to our customers. Thank you for your attention and interest in Robocars. We are now showing our demonstration and then ready to open to any questions or discussions you may have. Thank you.
Now we will demonstrate how the robot will going to assist customer in supermarkets. Our robot will have three major functions, which are item navigation, follow customer, and location navigation. The first is follow customer. The function help customer to free their hand from trolley and concentrate in shopping. Customer can activate the function by follow me command and deactivate the function by stop command. Follow me.
Start to follow.
Find counter.
Stop.
When customer do not know the location of item location, they can ask robot to show the direction. Find keyboard.
Find keyboard.
Besides, customer may not know the location of some places, such as counter, customer service kiosk, or car park, so they can use the location navigation features to help them to find the direction. Find counter.
Find counter.
With this feature, customer able to have a seamless shopping experience.
That's all. That's all our presentation and demonstration.
Thank you. So we Q&A, judges, question.
Hi, I have a question. I'm Nadia from Intel. I want to ask the team, like how long it takes for the robot to initialize the specific users, the specific customers. Yeah, and then how do you avoid it follows other people in the supermarket, right? There might be a lot of people. Then how do you avoid it follows other customer? Yep.
The duration for detect human function, it really depends on where's the customer stand, and if the robot can detect the human, as long as the human is in the capture area, it will continue to follow the same customer.
I guess the initialization is where the customer will, I mean, I don't know, maybe capture the robot will capture the customer's photo and then detect the specific voice, right? Is that correct? My understanding correct?
As you talk to the robot and say, follow me, then the robot will capture the customer's location, but the customer must stand in front of the robot first.
So if there is a maybe mischievous kid stand and talk in front of the same robot of other people, then it will follow as well?
The following function of the robot is the robot will catch the largest area of the customer, so who stand more close to the robot.
Other judges?
I have a lot of questions. So, did you all do any research before you came out with this idea? Like, is this really a problem? Like, how do you know that? Did you talk to anybody? Hello?
No, we don't really talk to anybody. We
Okay.
just discuss
Okay.
with the supervisor.
You just discussed amongst yourself and then decided this is how you want to solve that particular problem about finding a product, but you don't know whether it really is a product, is a problem, right?
No, we're sure this is a problem. It's just not sure it's really a common problem for the whole market.
Okay, never mind. How did you come up with that cost of 15,000 and then a selling price of 80? Can I assume again? Let me just clarify this. Is this like a personalized cart for every shopper? It is, right? Like a follow me cart or something, a basket, right?
Yeah.
So how did you come up with the 15,000 cost? I think I missed that. Probably you must have shown a slide, but I think I missed it. Could you just very quickly summarize for us? Like, how did it cost 15,000?
The cost is actually for the scatter robot only, because our external components is not really use that many high cost. So our cost is depends on the scatter robot.
Okay, so then you will sell it to the supermarket for 18,000. That's your proposal, right?
Yeah.
And you will sell how many units per supermarket? Let's say you showed Lotus, I think. How many do you think Lotus may purchase from you? Let's say if you do it. At 18,000, do you know how much a card costs, a normal card cost? Any idea? Did you do some research?
No, but I think it's not that much.
Okay. All right, I don't have any more questions. Thanks.
Any more?
Hi, Tim. Asmadi here from MPC. I think I agree with Shaji because from my point of view, when we come up with the proposed solution, we have to clear in terms of the problem statement first. We have the baseline or data before you do the improvement. What is the indicator that to be measured? So I believe the practicality of the solution is important, but I think for improvement you have to do more engagement with the potential clients, especially you mentioned about warehouse and hypermarket, whether it is okay to have investment 15K, if I'm not mistaken, more than 18K to buy this robot, because as I mentioned, the practicality of the innovation solution that proposed is vital before we decided to go or to invest on to invent the new idea in the technology. So in terms of the solution and engagement, you have to study and to improvise. Improvise. I think you have the idea, but please clarify with your potential client first before you finalize the features and also the uniqueness of the solutions. Thank you.
Okay, thank you for the suggestion.
Okay, Najib from Ranti here. My suggestion is just to relook on the feature of asking the robot of where can I get what pasta or something. Well, you may need provided that you have access to the inventory of the supermarket, and who will have to update that set of inventory. So that cost is not factored into your 17,000 or whatnot. But yeah.
Okay, thank you.
Any other questions? So if not, thank you, team.
Okay, thank you.
Yep. Yeah, you may leave the judging room now. Thank you.
Okay, thank you.
Judges, you can start scoring. I'll give you 2 minutes before we bring the next team. Assalamualaikum, Khairul. How many people from your team joining?
For 5%.
5%, okay. So we're just gonna wait for them to join the session. So the next team is team Robotron from USIM.
Yes. So we use the same device for the 5%.
Your other teams are coming.
All of you.
Or just gonna stand in front of the. Okay. All right. You have 15 minutes for your presentation and 5 minutes for your demo, and then 10 minutes for Q&A for the judges. Whenever you're ready, you can start. Yeah.
Ready? Thank you. Right, can you see the slide?
Yes.
All right. So I guess we can start now. Hello and good afternoon, everyone. To all judges, thank you for your time and thank you for giving us this opportunity today. I am Fakrazi.
And I am Amni Farisha.
We are Robotron USIM.
For your information, all our group members are together with us in this room.
Let me ask you something. Have you ever experienced any difficulties using a shopping cart? If you are not, you are lucky enough. But if yes, then this is for you.
We call our solution an in-cart.
In-cart, your intelligent shopping companion.
With dual mode configuration, mall mapping, and obstacle avoidance features, it will bring you a new shopping experience.
There are two major events that frequently occur during shopping. The first one is finding your desired items. That's for sure the most common issue, right? Then cart maneuverability. So Robotron aims to design a shopping cart with dual mode configuration, person following, and autonomous guidance shopping cart.
The issues mentioned by Fakro just now is agreed upon by our respondent, with 74% agreeing on maneuver issues and 80% of our respondents have navigation issues, with more than 80% prefer AI shopping cart.
Our respondents expect that the cart will benefit the needy, have an AI-guided solution, a user-friendly, and flexible.
Well, it's time to introduce the shopping cart. It is operated with a 10-inch digital display, a real-sense camera for object detection and product scanner, and a LiDAR for surrounding navigation.
This shopping cart is supported by aluminum profile with a height is around 98 to 106 centimeter range. It also has a set of driving and caster wheels.
The in-cart is developed based on these three main flowcharts, which is based on our three main functions: follow, GUI, and guide functions.
Shown here is the actual in-cart design developed by Robotron USIM. So, judges, you can see from the left or right view, then from the frontal view, And the most importantly, from the top view, you can see the monitor and the space for the basket to fit in. And lastly, the rear view of the in-cart.
While this is the in-cart user interface, with the main selection mode pop up as the user presses the start button. The user interface also has its advertisement and mall mapping sections.
Proudly present here the existence of the first Southeast Asian AI infused trolley deployed at Reptic Shafburi, Putrajaya, a Malaysian smart shopping trolley based on artificial intelligence.
This smart product has technologies such as barcode scanning, product verification, and a combination of advanced sensor features that can avoid the risk of theft. As we have done the site visit by comparing EasyCart and InCart, InCart provides enhanced features to the smart shopping cart. By having an autonomous following person and auto-navigating product, we hope that InCart will be the game changer in smart shopping innovation.
You are here today witnessing the InCart development and progress. Aim for deployment at any shopping mall so that it will benefit everyone. It is anticipated to increase the visibility and attraction of the mall, generate revenue through advertisement, and improve the management of shopping carts.
From our perspective, it is believed that InCart will be more convenient, reduce time waste on unnecessary processes, and above all things, it will improve shopping experience.
The InCart development has incurred approximately 10,000 ringgit Malaysia by taking into account the cost of shuttle AMR kits, advanced sensor, trolley frame, fabrication, and 3D printing.
Before we end this, let's together watch the demonstration of InCart.
Welcome to a live demonstration of the Intelligent Cart, your intelligent shopping companion. This cart comes with 3 special features: guiding, following, and barcode scanning. This is guiding features, which is auto navigation cart mode. Users will interact with the GUI interface. To select the desired mode, when the user presses the guide button, they must choose the product category they wish to find. And then the cart will automatically navigate to the desired location. Thanks to LiDAR technology, the mall map can be displayed, and the product's location will appear on the map, as shown on the monitor interface. This feature helps users experience an efficient way of shopping without struggling to find each product's location. Next, following feature, which is human tracking and user auto-following cart mode. Users will interact with the friendly GUI interface and choose the following mode. This intelligent cart will automatically follow the user to any location the user goes. With the real sense camera's capability, the cart can follow the user without interruption. This autonomous shopping cart offers significant benefits. To individuals with disabilities, its user-friendly design, including a simple monitor interface and maneuverability features, which make shopping more accessible. Moreover, the cart's autonomous capabilities enable it to guide and follow users, eliminating the challenges often faced while navigating stores. Overall, this cart empowers individuals with disabilities to enjoy a more inclusive and stress-free shopping experience. Let's see the barcode scanner feature, which has price scanning function. When users select the scan button, they simply find and scan the product's barcode using the RealSense camera. By utilizing artificial intelligence AI, this cart can scan the product's barcode, and the price will be displayed on the monitor interface. For user acceptance test, we try to get potential customer.
Assalamualaikum. This intelligent card works very well for me. The interactive guide is very easy to use. It follows the order that I put in, and also it gives me a very pleasant shopping experience using this intelligent card. I believe this card can be improved by having a larger card and make it a bit more faster and more responsive to the interactive guides that we chose from the monitor.
Okay, so far bagus, new innovation untuk mall. Cuma boleh difikirkan tentang weight yang akan kita put dalam trolley lah. Somehow macam common trolley, dia ada tempat baby duduk kat sini. So you kena fikirkan tentang itu, and then how far yang screen ni okay, friendly user.
InCard, your intelligent shopping companion. Special thanks to USIM Robotic Club for their tremendous support and help.
All right, thank you guys. I guess you already done all your demos, so open up for quick Q&A from the panel. Anybody want to start?
Okay, nobody's asking. I will ask. Hi, this is Shaji from Retailertics. So how much did it cost you to develop this product? Can you hear me?
Yes.
Could you give an indication of how much it cost you with the LiDAR and all that?
So from this, we made a calculation that we can say that approximately around the 10,000 in Malaysia. So
what is the most expensive component here?
So from this, you can see the sense camera is the most expensive.
Right.
And
okay. All right. So okay. So have you heard of something called planogram? You know what a planogram is? Don't know. Okay. So basically a planogram is what often it's a system, it's a software where retailers will plan where the products are placed on the shelf, which product goes to what shelf, right? The trouble with Follow Me, it's a good idea. I like what you showed me, but most retailers don't have a planogram, and some of them do, but they don't use it. And if it's not updated, Follow Me doesn't work.
I see.
okay, or even locating products won't work.
Mm.
You see what I'm saying? Follow me will work. Sorry, guide won't work. Guide won't work, right? So that's the issue. Okay, but great job. I'm going to do something which I didn't do for the other teams. I'm going to turn on my video so that you can see what I'm doing.
Okay. Stop sharing.
Great job.
Welcome to a live demonstration of the
I said
Okay,
good job.
guys. Okay, guys. Shaji, you've done your comment, Shaji?
Yep, I'm done.
Okay, right. Guys, Asmawadi from MBC, I think a good idea, a good presentation. And of course, you demonstrate your project to the potential clients. And just to clarify on the features or the in terms of inventory management, how you link the inventory management to your solution first, and also you have the chatbot and virtual assistant in your proposed project. I'm not sure. Can you clarify on this?
The virtual assistant. Can you repeat the question?
First, regarding on the inventory management, whether you link with the your solution or your system, and second one in terms of the chatbots and the virtual assistants that you integrate in your system or your solution, whether you have the features to include in your cart, or what is your solution name? Cart.
Yes, the shopping cart.
The shopping cart. Do you have that element that you integrate in your solution?
So basically that what we plan, but in the limited time we are not able to do to further do to that much until the solution can link to the inventory management. So we just produce this solution and make sure it work perfectly. It is answer you.
Okay. So what the chatbots and the virtual assistant, do you have that functions?
For now, no, but we plan further. We will
So you plan to enhance the features or the uniqueness of to develop the extra features for the systems. Okay, right. Thank you. I think good idea. Good, very good.
Thank you.
Any question from Intel or Najib? Nadia?
Oh yeah, yeah, good presentation, guys. I just want to know because I saw that the position of the LiDAR is at a bit behind. I just want to know if your LiDAR is actually working properly because it's a bit like hidden. Yeah.
So from the slide you can see that we have mentor from Move Robotics, and we also talk about the position of LiDAR, position of camera. So what he mentioned that if we put the LiDAR there, so it will work properly, and then the obstacle there, it can be removed in the system.
Okay, but on the actual when you do the experimenting, do you see any problems due to the position, or it's all right on your side?
It's all correct and it will properly.
Okay, yep, that's all my question.
Thank you.
Ari Najib from Ranti. So yeah, good job. What I really appreciate was that you've already looked at it from the perspective of the user. Even apa benda ni, even the height of your trolley was already thought for. Even your video and your demo was done through the lens of the user, very easy to relate to. less jargons and less information on the technology. Good, but again, for me, I mean, thumbs up, because in terms of the storytelling, it was very clear. Yeah. Shaji, you should take a photo with your company's background, but I'm sure if you're at the office, I think then they will give you, it will give um, our mentees here more visibility on your competitors, on their competitors.
Thank you.
That's why I said you should do a little bit more research, because it's great ideas, but not very practical for this market. That's the only problem. Yeah. Small
Yeah,
market.
but great thought process.
Yeah, fantastic thought process.
All right, any more questions? If not, thank you, team from USIM. Robotron, you can leave the judging room. Thank you.
To all judges, thank you for your attention.
Thank you.
Good luck.
Thank you.
Judges, you can start scoring. Give it 2 minutes. Yeah.
This was a good team, Azmi.
Yeah, they kind of blow my mind, because I actually had not followed until the end what they're doing. I know they were doing something, and you know, I'm pleasantly surprised they came to this. To be honest with you.
Yeah, the thing is this. I was thinking, I haven't seen such a well presented, a good presentation even from big companies.
Yeah. Well, okay, so let's leave the discussion at the end. After all the teams have presented, we get more time to discuss further. All right?
Yeah.
I can say how many people of you joining from your team?
Hello.
Yeah, how many people from your team is joining?
Only me.
Just you. Okay. They're just ready?
Yep.
Yeah, so yeah, you can start whenever you're ready. Yep.
Okay.
You got 15 minutes presentation, 5 minutes demo, and 10 minutes Q&A. Yeah?
All right.
Right, all the best.
Hi everyone. I'm Kin Singh. I'm the group leader for Team Squad Starlight. The title for my project is the development of an autonomous mobile robot system for on-shelf inventory tracking and inventory price mislabel in retail industry. The topic outline for this presentation is firstly the problem statement and objectives, software tools used for this project, and the system design and architecture, the ROS node graph, the environmental setup, and then I will update you about our work progress and the market value of this project and the summary. Okay, the problem statement for this project is firstly, there are incorrect price labeling of items due to human mistakes in retail shops. Then it's very time consuming for the people to check for inventory balances manually. Thirdly, is the misplacement of the items in different locations by the customers. So the project objective to develop this project is to develop an autonomous mobile robot that can navigate retail stores and identify products. Secondly, we develop a system to detect the on-shelf item availability, identify the incorrect price labeling, and detect misplacement of items. And finally, we integrate the system to automate inventory tracking and inventory price mislabel in retail stores. The software tools we use in this project is firstly the ROS tool Foxy. Secondly, we use open source computer vision library, the OpenCV, to code our image processing task. Then we have a database, which is the django MySQL framework. After that, we have a GUI to show the data. And we use the PyCharm community additional IDE to code our programs. So let's move on to the system design. This is the system architecture of our project. The top level there, we have the data distribution service, and this data distribution service, we connect all the 4 components, which are the SLAM, navigation, and localization, which for the mapping and autonomous movement of the robot. Then we have the image processing task, and we connect it to the MySQL database. Then finally, we have the GUI. All these 4 tasks are connected together under the data distribution service of ROS2. These are the source files that we currently develop for our project. This is the ROS node graph, which to get the data from the robot sensors. We use the CMD velocity the most, which the speed of the robot to navigate. To test our system, we actually set up an environment. We actually bought some shelf for testing the functionality. So we tested at the AMR kit camera, which the RealSense D455 needs approximately of 40 cm range from the rack itself. This is the work progress for our project. So currently, we have the navigation module done by 80%. Then the barcode scanning and price mislabeling by 80%. We still haven't done the item counting yet. We have done the database for data storing and GUI for data display, still haven't done yet. This is the market value that the project will bring. Firstly, is a efficient automation. This can reduce the need of manpower in price tags, inventory tracking, and item placement verification. And secondly, operation costs will reduce. It will reduce the cost of hiring manpower to do the manual job. Then finally, this project can scale. The MRs can be scaled as the size of retail operation grows. It changes in the store layouts or product placement can be adapted. So to summarize, the problem exists in retail shops are incorrect price labeling. Secondly, the need of manpower, inventory balance check, and lastly, the misplacement of items by the customers. The objective of this project is mainly to solve the above problems by using the MR with computer vision and image processing functionality. The progression of task list. Hello? Can you all still hear me?
Yeah.
Yes.
Okay. So I saw someone muted me. Okay, the progression of tasks listed here are almost 60% to 80% done. The market value of this project is to ease the operators to do the manual error and item balances checking, and thereby to reduce the overall operation cost and improve efficiency. So let's move on to the demo. This is the navigation that we have done for our MR. Okay, that's all for the navigation. For now, we just built 2 racks for the navigation for testing purpose. Then now I will show you the image processing. Now we are running the Django framework for database. In here, in this URL, we can set who is the admin and the password. Then we can set what are the items inside the retail shops. And the price as well. Then to run the image processing part, we have to go to this OCR URL. This capture is to capture the image. Then after we have captured image, we run the views Python file. Then it will resize the image and get the price tag and also the barcode as well. I didn't show in this video. Then after it process everything already, then it will show the results here. So for now, we still haven't coded the checking yet between the database and the image processing. So in this demo, I just cross-check between the database and the results that we get from the script. In this first item here, we purposely put the wrong item to later do the checking up. So, but this second barcode here is the correct one. This is the image file that we have just captured from the camera using the capture command. Okay, so that's all for my presentation and demo.
Thank you. Let's open for Q&A from users.
Hi, Najib here from Meranti. What got you to decide on this problem statement, on this project?
Firstly, we read some research paper from the online sources. Then from the Catapult, the EMA competition official website, there's the issue and challenges. Then we pick it up from there.
Did you manage to validate with maybe some of the retailers or logistical players?
Last time, the general manager from Pavilion, she mentioned that the retailers need the inventory checking and price scanning by 51%, which is the highest.
Okay, right, thank you.
Insane. I have a question. This is Shaji from Retailitics. So I thought your presentation started with a drone, and then eventually I saw the scuttle robot. So is there a relation between that, or was it just a picture?
It's actually just a picture.
Okay, so here's the thing. I just saw a robot moving. You didn't say anything, so you didn't explain anything, and I was completely lost when you showed that video of the robot moving, the navigation part, right? What exactly was happening? I mean, what were you trying to achieve there? Because here's the thing. So I'm thinking the way it should work is go scan the shelves, see where the products are, see whether anything is out of place, and then transmit that data back to the store office or whatever, right? Is that what you're trying to achieve, or?
We are trying to achieve to bring the robot in front of the shelf to scan the price tag.
Scan price tags. Price tag, okay, on the shelf, okay. And do what? Sorry.
Because we actually read some papers, they say that there are the human errors in the price labeling.
Yeah, so exactly. My question was, you're scanning which price tag? The price tag that is on the shelf for the whole category there. Say, for example, it's Milo packets, right? So, when you go to a supermarket, it says Milo is 4 ringgit 50 cents or something, right? Is that the price tag you're scanning, or is it the actual products on the shelf?
It's the price tag and the barcode.
Okay, never mind. I'll leave it to the rest of the judges to figure this out.
Hi, Kinsan. Asmawadi from NPC. I think the idea is to improve in terms of inventory management, and not much I can ask you because the solution, the prototype is not ready yet. It's not ready yet to test. So just to clarify, how the solution, as mentioned by Sajid, how your solution can improve in terms of the inventory, and how long in terms of the I would say, if you can compare before and after, what is your projection when we have this the solution? What would be the measurement before and after by having this solution that we can offer to the potential client? Thank you.
So the idea behind this project is to when we close out the stores at night time, and when nobody is there working at the stores, then we can use this robot to do the automation to help us to scan the errors on the shelf. So after the night ends and then the day starts again, then let's say the operator will have the full report of the status of all the shelf inside the retail shops. So for now, we have just done the price mislabeling and also the barcode. Barcode is to match which item which it belongs to. So we can match it to a database to do the cross-checking. And then
I think I just make it sure I understand what your intention. So for improvement, as mentioned by Encik Najib, it's good to have the data for the baseline study that we have for you, if to compare later on after you have your prototype, you test your project, you can have the better outcome to show to your potential client. That's my suggestion. Thank you, Kinsey. Right.
Okay, thank you.
Yep. Hi, I'm Nadia from Intel. I think one thing for improvement, maybe in the future, you can add on more on the user, on the AMR flow, what you are trying to do is what you mentioned just now, because I think that is quite unclear on our side here. It's more on the features that you have rather than how the AMR flows. And I have another question. I have a question. Then, because you said that there will be inventory checkings and things like that, assuming in warehouse where there's thousands of items, do you have a plan to connect the robots to a server where to double check on the inventory side? And yeah, and another thing is because I see that you try to do a lot of things inside the robot, which is the OpenCV, the navigations. Is there causing any lagging on the robot side? Yep, that's all from me.
Yes, our code there's the connection between the server and the code, the data, and then after we get the data from a process script, then we can compare it with the data from a server. Then we can generate the report to the operators. The scripts, the programs that we write, we didn't have any lags so far. It's a very powerful processor that's sponsored by the organizer.
Any more questions? If no more, then thank you, Kinseng, for your presentation. You may leave the judging room.
Okay, thank you, everyone.
Thank you. Judges, you may start do your scoring. Thank you. Hi, Zikwan and Zijun. How many of you joining from your team?
There are three people, but one is joining. Yeah, the line is a bit slow.
Okay. So just wait for one more person. Yeah. Zico, I'm not gonna pronounce the name of your team because depending how I pronounce it, may not sound too good. So I'm gonna mention about you're from Utah and your project name, right? So it's kind of tricky to pronounce the three alphabet together.
Which team is this?
I will not say it, Shaji.
Yours.
They got very nasty name. Depending how you pronounce it. So.
Actually, our team is called URS. Actually, it stands for Utah Robotics Society.
Yeah, that's why I do not want to pronounce the alphabet. So it sounds too too kinky.
I can see why.
Okay, can I share my screen?
Can we start? Yeah. Are you waiting for your team member, or you can start now?
Yeah, the other teammate is joining now.
Okay, all right. You can put up your slide. Yeah. So you got 15 minutes presentation, 5 minutes demo, and 10 minutes Q&A. Yeah. Okay.
Okay, 15 minutes of presentation and 5 minutes of demo.
Demo, yeah. You can combine the two if you want to. Right. Okay.
All right.
Start when you're ready. Yeah. All the best.
All right. Thank you. Okay, can you see my screen?
Yep.
Okay, so we will begin our presentation. Yeah. So okay, first of all, we are Team URS. Stands for Utah Robotics Society. So my name is Lim Zikwan. This is my twin brothers. My name is Zijun. And on the other side is my juniors. Actually, it's junior. He is my senior, but I'm older than him, so it's a bit complicated. So his name is.
My name is Uisu Jack.
Okay, so today we will representing our project for the Robofun Hackathon 2023. It's called Multi-Role Automated Robot, or short form it's MAR. So first of all, let us just briefly go through our problem statement. So since 2020, COVID-19 hit the world really hard. So especially in like service sector and manufacturing sector or any kind of sector, people need to practice social distancing. So this causes a lot of issue, like people scared to like meeting each other or something like that, especially in workplaces. That's why this caused a lot of this caused the issue of shortage of workers in Malaysia. So although COVID-19 is, come to an end, almost end. So but according to Malaya Mail, until 2023 January, they are still like short of 1 million foreign worker post pandemic. So which means that it's still lack of workers in a lot of sector. So especially in the service sector, it's lack of almost 100,000 workers, which is the main sector that we are aiming for, is the service sector. So the other problem statement that is we want to, as technologies are growing, more and more services like sales or something like opening a shop through online platform like Shopee, Lazada. So although these sales are doing the marketing through the online platform, but they are still need someone to manage the back end parts, like managing the stocks, collecting the order for the customer to to ship out to the customer. So all of this need people to do it. So plus the lack of workers in now days of we need like multiple robots to solve multiple tasks. We just use one robot for
Zikwan, sorry, I
Hence,
can't hear you.
on the thing that is connected to, the equipment is attached to. So let us go through the objective. So like I mentioned,
Yeah.
we want to investigate possibility of now better. Okay.
Proceed.
Okay, sorry. It's a bit far to my laptop. Okay, sorry. So so this is this is our objective. So our objective is we want to investigate the possibility of implement automated multi-row system in hypermarket or something similar, so that it will improve the efficiency of the works. So the second objective is to access the features of required such as automated picking, cleaning, stock arranging with a single robot. Like I mentioned just now, that we are introducing a single robot that can perform multiple tasks that can attach to different equipment or tools. So the next one is to develop a robot capable of solving worker shortage issue. So this is the main thing. So I believe that if we can use one robot to perform multiple tasking, so that it will reduce the needs of workers, so that it will solve the workers issue, shortage issue. So the last thing is to make the recommendation based on the challenges faced and solving labor issue. So actually this mentioned that some of the company are facing labor issues, such as the workers are having a bad attitude or like lazy or something. So with the robot implement into the system, so I believe that it probably will solve this kind of issue. So next, I will move forward to the robot design of the design of our robot. So on the top left, we can see this is the base of the, the left side is the base of the robot, which is our main robot. And then on the right side, it's our trailer. This trailer, it's not specifically looking like this. It can be like something like cleaning robot, cleaning trailer, or stock arranging trailer. So for this demo purpose, we specifically designed this. It's called the grabbing trailer, which means that it will grab the order that requires from the order. Based on the order, this trailer will go and pick up the things that are following the order list. So how the robot will function is that the base robot will go under the trailer, and then it will latch itself, and then the whole thing will become one module, so that it will move around the hypermarket to pick up the stocks or the orders for the customers. So initially, we're using center drive for the base. You can see on the top left. So using this design, initially, we think that with center drive, the robot is able to turn in a circle without compromising large surface area. So with this design, we somehow find out that if the floor is uneven, sometimes the robot will get stuck in the middle of, let's say if the floor is not even, it will get stuck in the middle of not even places. So later on, we change back to front wheel drive. So this solves this issue, and this works flawlessly. So for the base, actually, is the Intel Scuttle robot base. We just take it and modify it so that it works better. We put some modification inside. Later on, we'll mention in the electrical design part. So next, I will move on to the mechanical design. So for the latching device, we just use a basic 15 kilograms of the 15 kilogram servo to latch the trailer. So basically, after the trailer going in, then somehow it will trigger the trailer to latch towards the robot so that the trailer is stick to the robot and move together with the robot. So the second mechanical design on this robot is the gripper. So for the gripper, we choose to use the compliant mechanism. So this allows us to use the gripper to grip on different surfaces. Because of the compliant mechanism, it can curve as its grip on the curved surface. The gripper part, the grip part of the gripper will curve towards as the force of the servo is applied. So it will curve itself to grip on something following the shape. So for the last component that we design in this robot is the trailer wire connector, which means that the trailer somehow needs some power and data communication from the robot to the trailer so that the robot can talk to the trailer and ask the trailer to perform a specific task. So initially, we're planning to use a magnet connector for it, but somehow we find there's a few issues and somehow it kills one of our computers. So we change the design to you can call it push pin or pogo pin. I'm not sure what's the real name, but we just call it push pin connectors. So next, I will let my brother Zijun to continue with the electrical part. Okay, now I will continue to present the electrical part of these machines. So the driver of the robots is actually using Cytron motor driver, which is sort of smart motor driver. And for the trailer, basically both robots and the trailer, their motion actually controlled by the Arduino. Each Arduino, which means the robot has its own Arduino and the trailer has its own. So both Arduino will talk to the main processor of the robot, which is the computer on board via the serial communication. So next, I will continue to the server design, which include in the software system. So the server interface design, basically we are using the service provided by Google, which are the Google Spreadsheet and also the Google App Scripts. We choose to use the Google services because it is free and it's packs some powers. Then we just need to design the user interface using the HTML and also the JavaScript, and then all the logic and the program, basically we just store them inside the Google Spreadsheet, including the stock inventory, the data management, login, logout system, credentials, and so on. All the system, we just save it inside the Google Spreadsheet. Basically, it's just an online version of the Excel sheets. So this allows us to easily verify and understand the information and data if something goes wrong. So who will have access to all this data? Of course, is the user, but the user only interact with those data inside the user interface. And the next is the system developer and system admin. System developer will access the data at the back end because they are constructing the system. The system admin only access the data inside within the Google Spreadsheet, which means they don't have the direct access to the back-end program. And also, lastly, is the MAR rover itself. It will access to the spreadsheet to grab the information that the user place an order, then the robot need to like identify what's the item that the user requests, and the robot will go pick the items that requested, and finally then the robot will update the status to back to the spreadsheet to let the developers know that the task has been performed. Next, Sujek will continue to the software system, but for the navigation side.
You have 2 more
Hey,
minutes.
good afternoon. And so my name is Uisuja, and now I will be presenting the software part, which is the navigation and the trailer for robot. So in this slide, the figure here is showing how the robot is communicating between its components and then the trailer. Because there's a lot of things, so to summarize how the robot works is, firstly, the robot will look for the order from the customer, which is mentioned by my teammate Zijin. And once an order is placed, the robot will detect it. It will collect all the information of the user's order, and then it will begin to move to perform some of the processes. So it will start by docking with the trailer, and after it has successfully made a connection to the trailer, it will begin to navigate to the shelves, which will place all our groceries or items to sell. And with the gripper mechanism on our trailer, the robot will command the trailer and the gripper system to grip the required items according to the customer's order. And after all the orders are collected successfully, it will begin to navigate to the collection station. Where's the collection station? The collection station is where the robot will park at, and it will inform the customer via notification or email or through other means that we will implement it in future improvements, and the information will inform the user that the order is complete. Now it is time for the user to visit the store and collect its order at the robot's collection station. So after the robot collected all the orders, it will senses that the user has collected the order, and it will return back to the trailer station to undock with the trailer, and then return back to starting station. So it returns to starting station, maybe to charge or to continue looking for new orders from other customers.
You guys, you may want to go into your demo.
And
Thank you.
so proceeding, this is our bill of materials, and here you can see that we use a lot of mechanical, electrical components, and also some materials for 3D printing parts, 3D printed parts on our robot. This is not really the complete list yet. It is just a portion. Yeah. So moving on. So what is our robot MAR's marketability and project value? We believe that our robot MAR is able to bring benefits to both the customers and also the retail sectors such as Lotus, Giant, and Aeon Big. So firstly, for the retail sectors, the retail companies will be able to increase their productivity by solving the labor shortage issues. because now they have robots to help them perform all the tasks that the employees will perform, such as collecting orders and other possible applications that you can find in these retail stores. And also, because it is robots, the company only need to pay the company that manufactures these robots, like maybe a one-time fee, and then the company doesn't really need to keep paying the robots paychecks. They just need to pay for some minor maintenance fee and other small fees that will actually increase their return interest. And so secondly, for customers,
Guys, you only have 2 more minutes for your demo.
Sorry.
You only have 2 minutes left for your demo.
Oh, okay. Demo lang po.
Oh, demo. So in short, for okay. So for customers, in short, maybe some customers are very busy, so they can perform. They can use the app to quickly order something, check some orders from their nearby retail stores, and then they just need to order, just like how you would use a Shopee app to make orders. And then after that, once the order has been collected, they just need to visit that place and collect it, instead of having to visit the store and look for the items, where are they and how much do they cost. Yeah. And that is the part for, okay, that's the part for marketability and project values. So
So next we will proceed to the demo session. So we will turn on the camera for the demo. So right now over here we have
Is it only muted on my side? Or is it on purpose?
Guys, you all are doing something, but you're not explaining anything, or we can't hear.
Yeah, we can't hear you guys.
I think we cannot hear.
Because we don't know what you're doing.
Yeah, but they're not muted though.
I don't think they can hear us.
oops. Oh, okay, sorry. Can you hear us?
No, we can't.
Yeah.
No.
Okay, now we can. Now we can.
Oh, okay. Because I already unmute on my iPad, but somehow it didn't record any. I mean, it didn't pick up the sound. Okay, so can we continue on the demo? So let me just change to the laptop instead of the iPad. Okay.
Okay, so let me repeat again. So this is our robot. It uses the scuttle to construct, which involves the computer and the LiDAR and some other components like the real sense camera. And so right now the robot is at its starting position where the robot will look for the orders. And now I will begin the robot's performance. So now I'm running the robot. Now it is looking for an order. And okay, now the robot detected an order and it will start moving to its trailer station, which is in front. And so now the robot will navigate to the trailer station. And so this is our trailer. So right now it is slowly moving backwards to ensure that the robot will be guided into the trailer so that it can successfully create a connection.
So allow us to interact with the robot because last night during our testing we damaged some part on the robot. So right now we have the alternative way to communicate with the robot. So we need to do this to complete the demo. So okay, the robot shall begin this sequence.
So right now it is initializing, and now the robot has docked and it is moving to the shelves. So like what my teammate Zishin previously mentioned, sometimes the floor will have bits of slipping issue for our robot because it's uneven. So this is something that the companies will have to check if they will use this robot. But in future improvements, we will have to use better wheels or other mechanisms to solve it. So right now the robot has reached the station, and now it is navigating. And now it is looking for the position of the shelves. Okay. So now the robot, currently it is moving to the shelves, but there's something that we would like to mention is due to some constraints like time and on the materials, we weren't able to implement the gripping feature yet. It's already there, but we haven't successfully linked it to the robot. So now we assume that it has successfully collected the orders. So now it has reached its pickup station, its collection station. So this is where the user will be notified of the order, and it will collect the user will go and collect the orders, and then after that the robot will detect it, and it will slowly move back to its it will slowly move back to its trailer station to undock with the trailer. So it's currently navigating. Maybe I can mention a little bit about how it navigates. So we are using ROS or Robot Operating System, and the version we're using is Foxy. So how it works is we use the navigation tool package to allow the robot to plan its path to the points that we designated it for.
Guys, you already exceed the allocated time, so maybe we just open for Q&A from the judges.
All right. Okay. Okay.
Judges, questions.
Okay. Sorry. Right now it's Q&A session, right?
Yes, round is Q&A session.
All right.
Okay, maybe I will start off. This is Shaji from Retail Ethics. I just want to, just a couple of questions only. So essentially, this is a pick and pack kind of, so the robot actually enables an order to be fulfilled, right? So you go to
Yeah.
the shelves, the gripper will go and collect those things,
Yeah.
right?
Correct. Yeah.
Put it in the basket.
Yeah.
Is that
Yeah.
correct?
Yeah. Correct.
So we didn't see any of that where the arm is moving and the gripper is going and taking those things, but I'm assuming those are things that you have in the pipeline.
So basically, this is the things we are facing up. So basically, the arm is we construct ourselves. So actually, it's just a basic two-axis robot arm. So why we choose to build it ourselves is because there's a few models available in our university, but somehow the specs is not enough for us. So we decide to build ourselves. So we try to build the.
No worries. I know that, but I just want to ask you. So, what do you think the gripper can? What's the maximum weight the gripper can hold?
So far we haven't tested the maximum weight yet, but so far we tested for some things like chips or water bottle. It's possible to
canned food and also soda.
Yeah, it's possible to grip those things.
Okay.
Also some simple boxes.
Yeah.
Okay. All right. Cool. All right. Thanks. That's all.
Hi, Najib here from Ranti.
Right.
So yeah, plenty of messages in your slides. Your slides, good that you've got as well, if I'm not mistaken, newspaper clippings or whatnot. Good that if possible, based on that newspaper clippings, then you straight away zoom to your next slides. What was to me was a bit disconnected where during the newspaper clippings and you were going on and on about things that are not in the screen, and I was struggling a bit in terms of understanding what is the relevance to what you were speaking and explaining to the slide that I was looking at. So improve on that one, but definitely there is a lot of opportunity to improve here. Demos, my comment is, yeah, practice more, guys.
Okay. Yeah.
Okay. Hi everyone. Asmawadi from MPC. Previously, you mentioned about Google and the dashboard system. I believe there is. If the project can be completed, you will not only have the robot, but we also have a dashboard to monitor and track the status of the inventory, which is good.
Yeah. Yeah.
Just to clarify whether it can be implemented or not. Thank you.
Sorry. What you mean by implemented?
Because you have the constraint for the implementation of the budget. So what I mean, whether it can be, can you achieve the objective to integrate all the robot and to monitor through the dashboard systems?
Yeah, actually for the system, the dashboard, everything is already complete. Now the only incomplete things is the motion of the robots, because recently we have sit for our midterms and also finals, like the previous 5 weeks. So we actually have to study and also build this robot. So the time is very constrained for us. But actually for the gripper's motion and also which means
if the robot is separated, like run the system individually, actually they are the only issue for us is to join the motion with the robot operating system. This is the only issue we are facing right now because of time constraining. Yeah.
Actually, this week is our final exam week. So actually, tomorrow we still have paper. Some of us still have paper. So the time is very constrained to us. This is the only limitation. I mean, the drawbacks of our project.
Yeah.
Sorry. Good luck for your exam, guys.
Yeah.
Okay. Okay.
Nadia, any question?
Yeah, I just want to know, like, hi, I'm Nadia from Intel. I just want to know if, I mean, if we have more times, then what are the improvements that you guys will do, especially on the gripper side?
Okay, so for the gripper part, to improve, actually, it's implement more degree of freedom into the gripper, and then enable the gripper to open up wider, because right now the gripper is only open up like only 5 to 6 cm like that. So probably actually this gripper is the version 2 gripper we designed. Actually, previous one we designed, the first one is can open up very wide, but the drawback is the grip force is very low. Yeah, so we want to compensate. We want to grip something very tight so that we change the design, but the size becomes smaller. Yeah, then for the robot side.
So for the robot side, currently we wish that we have enough time to complete the docking mechanism, because we, as shown in the slides, in the previous slides, we have a docking mechanism that will link the robot to the trailer. So in terms of like serial communication, but because of, I would say, some mechanical issues that we are still troubleshooting, we weren't able to implement it right now and successfully let it just dock in and then just let the robot move, like without any human intervention.
Yeah.
And for the navigation, as you can see on the robot wasn't really moving in a straight line or smoothly. That one is, I believe that we need to implement some filters to the motion. Yeah, especially PID control, make the robot move smoother. And also other improvements like some noise, removing some electrical noise, because like one of my teammates previously mentioned, our docking mechanism.
Guys, can I interrupt? We know that you're in a university and you have so many constraints and all that, so don't worry about all those things. We totally understand that. Okay, so yeah, we no need to explain all that. I think we get it.
Okay.
All right. So any more question? If no more question, thank you, team from Utah. I'm not going to mention the name again. And you may leave the judging room. Thank you.
All right. Thank you.
Thank you.
Good luck for your exam.
All right. Thank you.
Yeah, go focus. Yeah. All right, guys. Let's turn on our camera. I'll let you guys finish up the scoring first, and then we'll have a short section to discuss. And, always the last team, they're gonna take up all your time, and I mean,
I'm sorry I had to interrupt and tell them. Otherwise,
it's better you than me. I was gonna scream to them. I said, enough.
We get it. Yeah. No, but
Okay,
some of them are. I think they got some of them got their concept right, and they demonstrated potential. I mean, that's what I think I was looking for. The potential, not really a finished product.
They want to make it perfect. Every time they do, it's not good enough. Like, yeah, let's make it perfect again. So
yeah.
Right. So
I think they demonstrated some potential. Some of them are really good.
So we got 5 teams today presented. So the job of the judges is to look at this 5, right? Because the next one going to be the demo day on 21st of October in about 2 weeks' time. they have to actually demo the solution and be able to, I guess, we'll have a little round of judging and presenting what they have done, to maybe to you guys again and some new judges. But we want to see how we can select those that are ready to showcase and have a good, steps to show to the people that coming to look at the demo and have a good interaction and so we need to I guess look at from the five, which one are you think are ready to go into the semi-final judging where they do a physical presentation, again, and then we will select from the semi-final, about 9 teams to go to the finale, right? So I'll leave you two guys to discuss.
So I have a question on what you just said, right? So are you looking at practicality as well? Because when I say practicality, I'm talking about what is the end goal for this, the demo day? Is it, do you have a product that can be commercialized? Did you get the concept of commercialization right? Are these questions that we should be asking?
Yes, that would be in the semi-final and final. We're asking those questions, but right now, I think with some of them, we see that they have a very good prototype and able to demonstrate the functionality, right? I think these are some of the good ones that can go to the next step where they can start thinking about, okay, now how do I monetize this? How do I deliver for the different user segment, different market, right? So at least they passed the first hurdle of building a prototype that demonstrate the functions that they need to deliver. Some probably not ready yet. They're still cooking up the ideas. So so just to give you an example, the last 2 sessions we had about on Wednesday and Thursday, we have a good numbers that well, from yesterday's session, about 5 teams, 3 was selected, 2 was not ready. I mean, they just have an idea. They don't have a prototype ready yet. The one that has a good working prototype and able to demonstrate that it's functioning, and maybe some small kinks here and there. So and like you said, it has to be towards commercial ready, right? Able to demonstrate is deliver the function. I guess our standard will be the guys from USIM. They have a complete product, but I don't think everybody will be like that. So that's a given one. I think the USIM one.
But with USIM, was it a complete product? Because some part of it, it looked to me that it was also a 3D rendering.
Yeah, but I think we don't think it's going to be a final product that's going to market. So now they're doing a first proof of concept. So there's still a lot of things to do. At least they demonstrate the function that need to be delivered, right? So I'll leave it to you guys for deliberating.
Yeah. So my concerns are these cost, because I look at some of them, right? They haven't thought through the whole thing. I'll tell you, USIM, I mean, I'm going to be very honest here. USIM blew me away, right? Fantastic team, very good presentation. They got everything right. They were, they just nailed it. But they only got, so I'm just looking at what they're doing, right? They only got around 60% of a go-to-market product.
Yeah, that's good.
Yeah. So that's why I'm asking. So demo day, what are you looking at, right? Because they haven't. If you complete 100%, then your cost will go up significantly, right?
So if you go to TRL, kind of a indicator, Shaji, it's probably like maybe 4 or 5 that we're looking at, not even 7.
Definitely 4. It has to be validated in a customer environment. Then it can go for 5.
Yeah. So from here, then hopefully they will, get the engagement. Like they should be talking to Shaji, say, hey, how to validate this to go to 7, right? So we want them to go to 7, but they have to have something to say, I'm 60% there. How do I get to 80%? Yeah.
Okay, so now they've done this stage today. Is anyone going to guide them going forward to help them?
So I'm looking at you.
Yeah, I mean, I don't mind advising. I'll give you, I mean, it's only us now, right? I can tell you, rack bots, right? 18,000, 15,000 cost, 18,000 end product for something that nobody wants.
Yeah, correct.
Not going to work.
Yeah.
Right? So I just crossed them straight away. USIM, I said higher. I actually put a comment saying higher. right? I will hire them any day, you know. Yeah. So, yeah. Anyway, squat straight. This is the last two, 4 and 5. They got the right problem statement. I think they are on track with the problem statement. It's just that I think they don't have enough time, or I have
Yes.
no idea. Something is, you know.
Well, I guess it's part of the development process, competition process. We cannot try to be empathize them because they don't have enough time. I mean, everybody given the same time, and they have to manage that, right? So we have to pick and
So here's my offer for this group, right? They are in retail. I don't mind introducing them to some retailers for an interview, right? Taking them to a focus group or shoppers. They can talk to them real time, right? Not an issue. I can set up all that for them, but they need to commit to that, right?
Correct.
So I can guide them, but you have to guide them in terms of presentation. Don't focus on technology. Nobody cares, right? Don't show us those diagrams. Nobody is looking at it.
I actually wrote that.
No, okay. So this year I was leaving it to all the university lecturers to guide them. I think I will not do that again for next year. They all have to come to how to present their slides, how to present the demo, what to focus on, what not to say, right? People are making excuses about I don't have enough time. I don't have enough people. Everybody given the same time. Everybody going the same training. So I cannot solve this basic navigation problem while other people did. So so some people are throwing excuses because they cannot deliver certain things. So it's not about that, right? So it's about, can you deliver what you say you're going to deliver in your problem statement, and do you actually do that, right? So this is where we need to say, okay, you said you're gonna make this based on the agreed challenge statement. Have you delivered that, right? And you're not competing against the rest. You're competing against, you say you're gonna do this, did you deliver that, right? So that's where basically the yardstick is what they have said for them to do, and do they actually do that?
Yeah.
Okay, let's go from team number 1, 2, 3, 4, 5, and then I guess you seem is very clear cut. Let's go, right?
But Doctor, I have a question here, because I think some of them, if we give them more time, then they have a potential. But at the same time, if we give them more time, it's only 2 weeks away, right? So
yes. So any improvement to be done is within these 2 weeks, and they have to actually achieve what they say they can achieve, right? So I'm not going to say it right now, but I guess knowing that if you give them this 2 weeks, they can put their time to improve. Can they actually deliver it? Okay, some I doubt, right? So
if you do want to give them more time, you have to do it across, not just for this particular track.
I'm not giving more time. We already fixed the date.
Yeah.
It's 1st October, so no more time, right? So if they're gonna miss out this time around, they can go to other competition, to improve further. So this is not the end of all, right? So this is not the only competition. There are other competitions they can go continue, and we want them to actually have that opportunity, right? So,
Yeah, so I was looking first at the problem statement, right? What will be where are they going? What's the journey of the retailer or the shopper that they're looking at? Which side of the problem are they looking at to solve? So the first 3 was more on shopping cart, and then sampai nak basi. The 4th one was is it another shopping cart or what? Might as well just bagi all those analytics, bagi dekat Shaji, that's it, right? Dah, all your free analytics, free research done. Then number 4 and 5 a little bit different, but they couldn't nail the matching between the prototype and their problem statement pula.
Correct.
And so but yeah.
Pity. Yeah, I don't know why everyone thinks a shopping cart is something that that everyone's looking for.
Maybe my mistake to putting your shopping cart into the challenge statement, say, hey, these are some examples, and now I want to be better than Shaji's shopping cart. Okay.
By all means.
Yeah.
So that was the thing, right?
Yes, nobody? Any any thoughts?
Okay, Doctor. I think I agree with the Mr. Najib and also Mr. Shaji. I think we have to stick to the the time frame that we proposed before, and also in terms of the project, we have to, maybe we can later on we can also advise in terms of the scope of the project. Sometimes scope of the project also met them the constraint for them to complete it completed the project, and also in terms of budget. That's why I think as mentioned by Cik Najib, problem statement and also the scope of project is important for the teams to initiate the project first. Right. That's my comment. Right. Thank you.
Yeah, you're right.
Kalau tak pun, the final participants straight away put it as they need to validate it with the customers lah. Kan?
Mm-hmm. Well, that will be in terms of how, I guess we want to see first what kind of self-initiative for these guys to say, hey, I need to go and validate from customers. So even the problem statement, some of these guys did not even validate the problem statement. So they just read, what we put on the website and didn't even go to the ground. I think, those who actually did the so-called user kind of interviews, user, observation, they know better, right? And when they refer to a product already in the market, like EasyCard, they know what's there and what's not there that they can have, maybe have an idea to improve. So it's a part of learning about it's not about technology. It's about learning what is the problem that you're trying to solve, and how is it.
But therein lies the problem, because they assume that we did not think of all that, right? For EasyCard, actually, we thought of all that. It's not practical.
They never asked you that question, so that's the thing.
Yeah. So they should have asked us, right? We would have told them it's not practical. You have no planogram, it won't work. So many things, right? Yeah. See, I didn't ask any of them, how are you going to keep the battery alive, the charge alive? If I had asked that one question, all of them would have failed. All of them. Every single one of them. All 5 would have failed.
I agree.
Right?
I agree.
I thought of that, but then I said, never mind, they're students. Don't dash their hopes. They are on the right track. They just need some guidance, So, yeah. Yeah.
So you guys going to give yourself a little bit more time to think it through, and then just reply on the group. Which team you likely to go?
I submitted already, na?
Yeah,
Okay.
I submitted already.
No, I'm talking about scoring is one. Consensusly, we agree on which team should go to the next stage, right?
Consensusly, berapa participant?
Berapa team dah ke?
I'm not going to put a number out. No.
I
can't hear you.
Yeah, I would like to see the last group in the finals. I don't know.
I think me too. I like that because I like the spirit, even though they're try to explain everything too technical, but they're doing something that is not common, right?
Okay.
Yeah. So there's also a good way to say, hey, maybe this idea works. Maybe not for us. We probably don't appreciate it, but never know, right? When out there, and maybe there's some people say, hey, this might work for me. So I don't know.
Actually, it can be developed further.
Yeah.
The likes of the shopping cart.
Yeah, I think even the Lone Ranger, the Squad Starlight, it's a good problem statement, but he got it all wrong, right? He was nowhere close to the solution.
I was validating whether I can hire him as my back-end developer, but tak boleh lah. Just simple coding tadi pun tak boleh jalan.
Tapi is he only one person?
No, he has.
That's what I'm assuming.
Team, but the rest are, I think, attending classes. So,
Okay.
So he's trying to represent all his team, with one-man show. So.
Yeah, but the timing of this has already been shared much earlier, right?
Yes.
Okay, Doc. So do we have to agree on one?
No, as many, even if you say 5, we go with 5. But you say 3, so we don't have to, I don't want to put a quota, right?
Okay. Just for the fun of it, okay? Just show which one. Just point to which one. All of us, come on.
Which
Let's
one is
see.
one? Which one is one?
This is one.
This is one.
Just point.
Point. Well, I would want to see 3 and 5.
3 and 5, okay.
Yes, me too.
Actually, I like to give a chance for number 1 because they may not have that high requirement, but they got the idea, right? So
I don't know.
You, Sanjeev.
Mine
No.
will be still 3 and 5.
Okay.
Yeah, I think 3 and 5 for me.
I also 3 and 5.
There you go.
I want to
Number
go with 4 as well, but
Yeah. So number 3 too, well, the mindset is there. They can do anything. That's where if we can infuse and navigate a bit.
Najib, the thing is this. If you want to go out and sell, right, you need the guts of 3.
Yes.
Right? The rest of them do not know how to sell.
Yes.
Ultimately, you can have the best product or the worst product, but if you give it to 3, they will sell it.
Yeah, Shaji, I know you want to hire number 3.
Team 5, you need to get a salesman for them.
Yes.
Team 5, you need to get a salesman for them. They get all the technical, they can solve that. You need somebody to sell it for them, right? They get into the technicalities and
Yeah, so the Zquan, the other twin, that can be developed as a salesman, but his messaging was too where.
Yeah, exactly.
Okay, so
Okay.
3 and 5 then. All right. Okay.
All right.
All right. Thank you guys. Appreciate that.
Thank you very much.
All right.
You can block your calendar on the 31st. I want you guys back to see how they have progressed, and they need to listen to you guys in terms of I told you to do this. Have you done this? What about this? What about that? Right. So the middle round of judging, it's grilling time for these guys because they really need to see that. Okay, I've got a technicality probably mostly done of 60% there. But now, how do I move into a product that gonna able to go to the market, right? So we need to grill them on that. Yeah. Okay. All right. Thank you, guys. Let's take a photo. Just 1 second. Just gonna snap one.
Shaji, open your camera.
Hey,
Doesn't
my
matter
camera
where
is
you are.
open.
Smile. 1, 2, 3. One more time. 1, 2, 3. All right. Okay, man. Thank you.
Okay.
Nadia.
Cheers.
everyone.
Have a good weekend.
Nice to meet you guys. Bye.
Nice to meet
Bye.
you too. Bye.
Assalamualaikum.
Waalaikumsalam.